In Uganda, it's a myth to find safe drinking water flowing straight from the taps. But here at Mbarara University, a team in partnership with Humasol and UCobs made it possible. And we caught up with them to find out how and why they did it.
The project was set up under the UCobs, which is actually a organization or a department within this university that has certain projects running. And our project is under subproject 3, which means making affordable energy and sustainable solutions for water available to everyone. So the idea came from the project leader of this UCOPS Institute, which told us that, or which gave us the problem. Our water here is not drinkable. We want a water purification system for the students on campus. Then we've mingled around a bit to see which is the source of water we are going to use. We have made a decision between the river Rizi water, a borehole, a rain tank, and our final solution, the national water. So once you want to do, you're interested in water purification, you have a first very important step, that is to know what is in my source water. So the first thing you're going to do without ever considering treatment steps is take a water quality test. Then you're going to compare this water quality tests with standards, and you're going to mark, okay, some of the components that are in there are not supposed to be there or are in a too high concentration. And then you're going to see, okay, which treatment steps do I need to get these components out of the water, and in what arrangement should they be made. Those are the steps actually in simplified order that you need to undertake to start a water purification project. So in our case, we saw that there was too much bacteria in the water, too much microorganisms. There was a too high concentration of solids, which we call total dissolved solids, or our turbidity was too high, and also our nitrites were too high. So we actually based our system on those 4 components because the other components were good. Also, this is reasonable since our national water and sewage company already takes some components out of the water. So the contaminants which are in our water are added maybe in pipelines or in unsafe storage. So we start with a storage tank of water. This is because sometimes the national water fails to provide, so we want to have a little buffer inside of our system for if this happens. Secondly, the water is going to go to our biosand filter. Our biosand filter actually has 2 means of filtration. One is physical, through the sand granules, larger particles will be retained and stay on the surface. And the other is biological. Your water contains some nutrients for bacteria to grow on, and these nutrients actually also pollute your water. Now we are going to work together with the microorganisms and give them this food so that they can remove it for us. Now when the pathogen enters your biolayer of your biosand filter, it will have to go into competition for these nutrients with the bacteria that are already there. So they will be eliminated since they are in a minority. So our biosand filter actually helps us with the turbidity, with total dissolved solids in there, and it also helps us with the bacteria. So the water now is in this tube, but it will eventually come in here, where the water will be spread over this diffuser plate. This diffuser plate will spread out the water so that the sand beneath doesn't get attacked by water, so that the water is going gradually. Now, the water will pass through all of the system to a pipe which is on the bottom and go all the way up again to this pipe. Now, the water you can see flowing off here is because we are still in initiation phase of our biosand filter. So actually, our filter does not work properly yet. We need some more time. In time, this one will close and we will let the water flow to this tank. This tank will store the water. Now, why do we have this tank? This one only filters very slowly. This one is very slowly. But this one, the activated carbon filter, will work very fast. This one will take 600 liters per hour, 700 liters, while that one will only take 50 liters an hour. So we have this buffer in between to ensure that this pump, which is going to be around here, can have enough water to go through our activated carbon system in time to go up to our tank. Now you see some more connections over there. That is because when doing maintenance, our biosand filter will need some flushing sometimes. This one is to scrape off the top layer. I told you about a biosand layer, the bio layer that will remove all the pathogens and all the dissolved solids. All these can then be discarded through this pipe also to a waste container. Also, this branch will be used after maintenance to ensure that our biosand filter is again operating smoothly.
We use an electronical system that controls when certain valves open, when the pump turns on. And this is all based on the water levels inside of the tank. You see here these wires coming out. They're connected to float switches. I can show you real quick. This is how a float switch looks like. So when the water level is here, it hangs like this. So then you know the water level is below this. When the water level rises, this is a weight, it turns. And in here, something falls down, and that makes a connection to be made and sends the signal to an Arduino system. And based on several levels, you can perhaps get a picture of the inside. You see, yeah, we base it on several levels to know when we can let the inflow come and when we can let it flow further. And that way we prevent tanks from overflowing.
The idea is that our system is going to be operated in a sustainable way. And since we are going to have to make some expenses, like for example our active carbon or even our batteries in time which need replacement, they will have to be funded in some way. And that is why we ask a bit of money for our system, just enough to maintain and to make some little improvements in case needed. So the system will charge you some money, but this money, the idea is not to make profit. It is to make the maintenance possible and to make future adoptions or implementations which can increase the efficiency or the productivity of the installation. So if you want to fetch water, you have to press this button first for the system to activate. Then you can drop your coin, which can be either 100, 200, or 500 in there. And normally it will go into the coin box, but now since the system is not powered, it will just return. It's also very hard to trick this system. Let's not say impossible, but very hard since it has 3 different sensors to see whether your coin is valid or not. Your 200 coin will fetch you 500 milliliters of water, and your 100, 250 milliliters of water, and your 500 coin will give you 1.25 liters of water. So you press the button, you drop your coin, and then you can use the valve to fetch your water. After your amount of water has been given, you can close the valve or it closes automatically since the water will stop flowing and you have your water. So in mindset of my organization as Humasol part, the system should have a direct effect, but also an indirect effect. Now, since we have been working with students who are attending an engineering school, we expect that the effect is also indirect. They will get the knowledge and take it with them to wherever they go. Not only that, but the system is made very robust so that the technologies can actually be replicated even in rural areas. Our system is also solar powered, so even when you have no connection to the grid, you could use this system to foresee drinkable water for maybe your village, maybe your other community. Now, our system has been designed to work for about 1,000 people, but it's also downscalable and it's also upscalable.
Yeah, I personally am so positive about this project. As the initiator of the maintenance committee student best, I am believing on the successive recruitment of students on the project team so that we don't have it collapse. Yeah, we had also thought of having it in schools because such projects are most required in institutions, let me say hospitals also. So it's still upon us, I will still say, that we have those ideas broadly discussed and we expand.
Have you taken on the challenge?
I would dare.
You dare to take on the challenge?
Yeah.
And we shall be happy to see you taking on this challenge.
All right.
Yes, thank you very much.
Thank you.